Any other questions on these guys? All right. So that's going to be that's the final process for the project. The report is worth 30% of the total overall grade. So let's talk a little bit about the final exam. So this one's going to be cumulative, and it'll be 12 questions where you complete 10 of them. That means you get to cross off two, right? It will be take home. Same restrictions as last time. So that means that you guys will be expected to. I'm going to expect that you're going to be using calculators, computer tools, your notes, that sort of stuff. You will still need to show all of your work for the mathematics. So, you can use like a different derivative or an integral calculator to check your answers, but make sure you're still showing all of your steps. And you may not consult outside human sources. So, once again, this is OpenNote, closed humans. So please do not ask outside human resources for help on these problems. And
Um,
it will be. Go ahead, Connor.
well, I know we're not allowed to ask humans for help, but say if I was working on a problem on the exam, like, could I ask my teacher for help on a problem that's similar to that, like has the same formula?
You could do examples of outside problems, yeah. But you may not ask them about the problems on the exam.
Okay.
Um, so the what am I gonna? Well, okay, I will assign. So I will give out the exam on the 6th at about 4 p.m. I'll basically make it available to you after class on the 6th. So after our presentations, after all your final project is turned in, I will make the midterm exam open to you, and it will be due at 4:50 p.m. on 5/11. This one, I cannot give any extensions basically for any reason. That is the last moment of class. Grades are due shortly thereafter, so I cannot make much extension. However, you guys do have a good 4 or 5 days to get through it, so it should be okay, I hope. Um, so, yeah, I think that's about it. Any questions about that test? We'll do a review. So we'll do some review on the. So Monday of next week will probably be our review day. Oh, I guess I should mention probably 5 to 6 of the questions on integration, and 6 to 7 questions on old material. So you should expect about half of the test to be new stuff and half of the test to be old stuff.
When when you say old stuff, does old stuff count from what we did on our second exam?
First exam, second exam, and third exam. Or I guess first exam and second exam. I forgot we only had two exams in this class. Generally, in the past, I've taken problems from previous exams and just reworded them, like changed a couple of numbers or something. I don't know if I'm going to give quite that much of a softball since you guys aren't actually taking the exam in class. So we'll see how that actually works out. Um, but yeah. Any other questions about the final? At least format wise, timing wise, that sort of stuff. Oh, I should mention, I want to be a little bit more strict about how you turn it in. When you turn in the exam as a single PDF file. So D2L is incredibly annoying about how it accepts uploaded pictures. It takes uploaded pictures and it rotates them all and it puts them all as separate uploads. So basically, it's just a giant pain in the butt when I have like 12 pictures to go through for everybody. Um, so um, basically, what I want from you is I want 10 pages, one page per problem. Obviously, if you need a little bit more than one page to do a problem, you can do more than one page to do a problem. Make sure every page is clearly labeled. With the problem number. And I would love it if it would be best if you guys could scan them using an app like so use an app like Google Lens or Genius Scan to take pictures. I'm pretty sure both of these two apps have the option to, when you take a bunch of pictures, you can collate them all together into one PDF document and then save that as a single file. That would be the best way to do this. If you guys are having any trouble at the time trying to get that stuff put together to turn it in, please reach out to me and I will help out. And we can figure out how to get through those technical issues. But I've had relatively good success asking other classes to.
How did my like I scanned my last
Yours
test?
did, yeah. Yours came out really nicely, actually. Whatever you did, fine. I believe I remember your test was very easy to grade, but some of them were. Mainly, it's the fact that that for some godforsaken reason, D2L automatically rotates every picture that it gets. So yeah,
Did you receive mine already?
I
Because I
believe I
put
did.
mine, I put all mine in the PDF itself. I just,
Oh yeah, yours was yes, yours was also very nice. That is a very good way to do that. Again, I'm just trying to give people options based on the tools that they have. The big thing I want one document with all of your work rather than like seven different photographs or something like that. It wasn't too bad when we only had 6 questions, but with 12 questions per student, it starts to get a lot more overhead. So
Could you read my good questions?
I could, but you were one of the ones that put a bunch of different pictures up, which was fine, but I would much rather you put them all together in like I could read your work just fine. I just had to go through a bunch of extra steps to actually get them to display correctly because D2L displays photographs very weird. So that's
Uh,
why I would like to use an app to scan them into a PDF instead.
Cause I just tried to get install Google Lens and from the looks of it I have to pay every month.
Do you have an iPhone or an Apple device? I think that there's a different version for like so Google Lens is free on Android stuff, but I don't know what it is like on iPhone stuff. Try Genius Scan instead. Um, but again, I'm definitely willing to look at other options. There should be a free option out there.
Can we um, also just put the pictures on like a Google Doc and save it as a PDF?
As long as I get your 10 questions on 10 different pages of some sort of document, preferably in PDF format, but document .doc is fine. It just needs to not be a dot like JPG or .png.
Right. Okay.
So that's why I'm saying PDF, just because everything goes to PDF. But yeah, whatever solution that you come up with to make that happen, 10 pages, 10 problems, um, all one document, do it. I will allow you to use anything as long as it looks presentable, right? So as long as it looks like something that you would actually turn in.
Adobe and Foxit PDF Reader, they both allow anyone to insert pictures into the PDF
Mhm.
itself. So you guys might be able to use that since
So the
you
free
use
version
all
of
three.
Reader of Adobe Reader lets you just insert photos into documents still.
I use Foxit Reader, but I remember using
Yeah.
Adobe when I was in campus, so I think
So I think the campus computers all have Adobe, like full blown Adobe Acrobat. They don't actually have just the reader. And the reader is
oh, my
actually
bad.
really, it doesn't do a lot. So Foxit is an option for PDF editing. It's kind of like the free version of Adobe. It's only vaguely free though. Foxit can get a little bit aggressive with its marketing pushes. So I don't love pointing people to Foxit. They install a lot of extra stuff on top of things. But if you want to use Foxit to input stuff directly into the test, that's also okay. Um,
I also pirated the software, so you guys should probably ignore me. Never mind. Sorry.
okay, so there you go.
I'm not sure if I can do this. I just checked Genius Scan as well, and I also have to pay for it.
All right, Connor, we will. I will talk to you separately about getting this done and making sure that you can turn it in correctly. I know that it is possible to do without paying for it. I had probably 20 students in my other classes figure out how to do this. So we will figure out a way to make it so that you do not have to pay for something, but you can still perform this task. But it should not be too incredibly bad. Actually, Emmett's idea is a really good one, where you just take a like a Word document or a Google Docs document and insert the photos into that. That might be the easiest thing to do. Well, it'll be the freest thing to do. Um, the apps are actually pretty quick if they're not asking you for money. I wonder if those apps started asking for money for all that crap because of the change in service
Except,
amounts.
except I don't know how to write math for formulas on a Google Doc.
So
That's
what
the
I'm
problem.
saying, Connor, and what Emmett was saying is that you can write on a piece of paper and you can take the photograph using your phone, and then you can put that photograph into a Google Doc. So that might be the easiest way to do that. But I can definitely work with you separately to try and make sure that you can do this. I can show you how to do it after the lecture today. So
Okay, thank you.
yep. Any other questions about any sort of admin stuff, exam, uh, final reports, presentations? All right, cool. So let's go ahead and jump into content. So we don't have a bunch of content left in this class, actually. At this point, I'm um, sort of like trying to figure out exactly what I want to do because there's a handful of different applications that you can do using integration, but a lot of them are A lot of them are aimed a little bit more at physics, or they're very in depth in economics type stuff. So today I was going to do sort of a relatively simple one, and it's pretty straightforward. It's a very geometric example. So this is the area between curves.
Also, what about if I send you the pictures of my answers on that separate Discord line that you sent me?
I need them to be in a single document on your D2L. Like they need to be submitted as one document on your D2L folder for the assignment, Connor, because I am trying to cut down on the amount of work that I have to gather everyone's stuff together to grade everything rather than add to that. So having you submit them to me in a special separate channel would be really difficult. That would add even more. But again, I will talk with you about this separately after class, and we can figure out how to do that. I'm confident that you're going to be able to do this, that it's not something that's insurmountable. So please try not to worry about it right now so that we can continue with the class.
I know. I'm sorry. It was just one question.
Yep, it's okay. So the application, this application that I want to talk about today is the area between two different curves. So, I mean, suppose we have a function, or two functions really. We have maybe some red curve like this. We'll call this f of x. And then we have some blue curve like this that we'll call g of x. And what we want to find is we want to find the area that lies in between the two curves. We'll call that A. Connor, did you have another question?
No, I didn't. It just for some reason I lost the stream for a second.
Okay. Is it back?
Yes.
All right, cool. So we know that if we just had f of x on its own, right, then the area beneath f of x, maybe actually we'll go from here to here, A and B. This area here, this is the integral from A to B of f of x dx. And similarly, if we just had g of x on its own, which looks like me not being able to scroll. Okay, let's try that again. Which looks like this. And maybe we go from A to B again. The area beneath G, that's the integral from A to B of g of x dx, right? So the area between the two curves should be the area of the curve that's on top minus the area of the curve that's on bottom, right? We have the area of F, and then we have the area under, G here. And then the area under F will do red. So the area between the two curves should be the red area minus the blue area, right? So the area between f of x and g of x is the integral from a to b of f of x dx minus the integral from a to b of g of x. We can make this a little bit easier actually, and instead of doing two separate integrals, we can just do a single integral because it's two integrals subtracted from each other, or with the same bounds, we could instead call this the integral from a to b of f of x minus g of x dx, where f of x is greater than g of x for all x between a and b. In other words, sort of to put it in a little bit of words, it's the integral from a, so the area between two curves is the integral from a to b of the top curve minus the bottom curve. So this is nice and straightforward a lot of the time when maybe you're given some bounds, right? We've just had bounds of a and b. So, for example, find the area of the region bounded by y equals x squared plus 1, y equals 1, x equals 1, and x equals 3. So what we have here is we have a bunch of different functions, right? We have x squared plus 1, we have y equals 1, we have x equals 1, and we have x equals 3. And we're looking for the area of the region in here, right? Between these 4 points. The region inside of this little box here, right? So if we were to sketch that, maybe it would look something like technology is being great today. Maybe it looks something like this. We're looking for this area here, right? And so in this case, our top curve is x squared plus 1. Our bottom curve is 1. And the vertical lines actually represent bounds. X equals 1, x equals 3. So the integral that we're going to set up is going to be the integral from a to b of top minus bottom dx. So it's actually going to be the integral from 1 to 3. Those are our horizontal bounds. We start at x equals 1 and we go to x equals 3. Our top curve is x squared plus 1. And our bottom curve is 1 dx. So this integral actually ends up being really easy. If we simplify this a little bit, we get the integral from 1 to 3 of x squared. It's plus 1 minus 1, so they just cancel. And to evaluate this, we'll use the fundamental theorem of calculus. We're going to take an antiderivative, and then we're going to evaluate it at the top minus it evaluated at the bottom, right? So recall FTC says that the integral from a to b of little f of x is equal to big F of b minus big F of a, where big F prime of x equals little f of x. Question? All right. So what's the antiderivative of x squared? Are you? Can anybody hear Vivek?
No.
Okay.
I
Just making
think
sure it wasn't me.
Oh,
something
there he
happened
is.
on
Oh,
my
there you
end.
are. Yeah.
Yeah, you were frozen, and I thought you were just really concentrating. And then I was like,
Oh.
wait, no.
Okay. Yeah.
Is
Weird.
the
My bad.
antiderivative x cubed over 3?
Yep. We're just using the power rule here. So we write that as x cubed over 3. And then we're going to put this bar at the end, which means that we're going to evaluate it. We're evaluating between x equals 1 and x equals 3. So that means that's going to be 3 cubed over 3 minus 1 cubed over 3, which is 27 over 3 minus 1 over 3. So that's 26 over 3. And that's the area of our region up there, between those lines. So this area in here has area 26 over 3, which is like 8 and 2/3 for those who prefer mixed numbers. So a lot of this is going to be just practicing with evaluating definite integrals, right? Does anybody have any questions about this example? Let's do another one that's a little bit less straightforward. I'm not going to give bounds. You're going to have to find the bounds for this one on your own. So, yes, Connor.
Where did we get the x?
X cubed over 3. What's the integral of x squared?
Two x.
That's the derivative of x squared. We're doing an antiderivative here. So the integral of x squared is x cubed over 3 plus a constant. So just a reminder that the power rule for integrals is the integral of x to the n dx is equal to x to the n plus 1 over n plus 1 plus a constant. So let's do another similar one. Let's find the area between f of x equals x squared and g of x equals the square root of x. So for this problem, we're actually going to have to find our bounds ourselves. We can't just, we're not just given the bounds, right? So it's a good idea to take a look at the graph. So you can find bounds by looking at the graph. So let's go ahead and graph those two functions. So here we'll graph x squared, and here we'll graph the square root of x. That's square root of 2, square root of x. So x squared's in the red, and the square root of x is in the blue. And we'll notice here that these two curves intersect. So the curves intersect at x equals 0 and x equals 1. So to reproduce our graph for the notes, square root of x looks like this, and x squared looks like that, and the square root of x looks like that. And we're looking for the area of this region in here. This is the point 1, 1, and this is the point 0, 0. So on the actual graph over here above me, that's those 2 points, 1, 1, 0, 0. And we're looking for the region between those. Maybe I could even, x squared is less than y is less than. Yeah, there we go. There we go. There's the region, nice and shaded in on Desmos as green. That's the area we're looking for. So that means our bounds are x equals 0, x equals 1. So we're looking for the integral from a to b of top minus bottom dx. And there's another reason that it's good that we graph this, because personally, if I'm thinking about x squared and the square root of x, usually I think of x squared as being bigger than the square root of x, right? Like 4 squared is 16, the square root of 4 is 2. So like this x squared function should be on top, right? And for most of these two graphs, that is true. If we're bigger than 1, our red graph is on top of our blue graph. But the region that we're actually concerned with here, the function that's on top is actually our blue function. It's our square root of x function. So our integral actually ends up setting up as the integral from 0 to 1 of the square root of x minus x squared dx, rather than x squared minus the square root of x. For what it's worth, if you get an answer for one of these problems, the area between two curves, and you get a negative answer, you did something wrong somewhere. And the most common thing that you might have done wrong is you just did it upside down, right? You did the bottom minus the top instead of the top minus the bottom. If you accidentally did that, that means your answer is right, it just has the wrong sign, right? So if we did this backwards, we would still get the same absolute value. We would just get the wrong sign on it. So here we want to evaluate this antiderivative here. We want to find the antiderivative. So we probably want to rewrite the square root of x as x to the power of 1/2. So we're going to rewrite this as the integral from 0 to 1 of x to the 1/2 minus x squared. And then we can do our antiderivatives, right? So the antiderivative of x to the 1/2, the power goes up by 1, and then we divide by the new power. So we end up with 2/3 x to the 3/2, right? So we're raising the power from 1/2 to 3/2, and then we're dividing by 3/2. Dividing by 3/2 is the same as multiplying by 2/3. I just don't like writing 1/3/2. That seems very ugly to write. So 1/3/2 is in fact equal to 2/3. And the antiderivative of x squared is still the same. It hasn't changed since the last time we did it. It's still x cubed over 3. And we're evaluating between x equals 0 and x equals 1. So let's go ahead and plug in. We get 2/3 of 1 to the 3/2 minus 1 cubed over 3 minus 2/3 of 0 to the 3/2 minus 0 to the 3/3. This back half here is all 0. And the front half ends up being 2/3 minus 1/3. So our final area at the end is 1/3. So that's the area of this green region between these two curves. The area between the square root of x and x squared is just 1/3. 1/3 of what? Well, I didn't give you units. If our graph was in scale of inches, then it would be square inches. But since our graph don't have units, it's squared unitless. So it's just 1/3 as a number. Does anybody have any questions about this example? Let's do one more quick example and then I'll let you guys go. Let's go ahead and let's find the area of the region bounded by 2x squared plus 10, and so bounded by y equals 2x squared plus 10 and y equals 4x plus 16. So because we didn't get horizontal lines for us to worry about, here we're going to have to find our intersection points again. So let's graph our two functions. Let's go ahead and graph. I'm just going to say, yeah, okay. Let's go ahead and graph the quadratic. The quadratic is 2x squared plus 10, and the linear function is 4x plus 16. This is not on our screen, but if we zoom out a little bit, it's up here, right? And if we look at this graph, we can tell that our linear function is on top. So 4x plus 16 is on top. And 2x squared plus 10 is on the bottom. Our quadratic function is on the bottom. And our points of intersection are -1 and 3. So let's set up our integral now. Our integral is going to be the integral between -1 and 3 of top minus bottom. So that'll be 4x plus 16 minus 2x squared plus 10. Notice that I am using parentheses here. That is actually important, right? Because we're going to need to, kind of like profit minus revenue, or profit is revenue minus costs. We need to subtract the entire cost function, right? So here, when we subtract these two, we end up with the integral from -1 to 3 of 4x plus 16 minus 2x squared minus 10 dx. And we can combine some like terms. 16 and -10 can combine. So reordering things, this becomes the integral from -1 to 3 of -2x squared plus 4x plus 6. I just wanted to write it in standard form because we typically see things from highest power to lowest power. We can do our antiderivative here. Our antiderivative will be, so the antiderivative of -2x squared will be -2/3 x cubed. Our antiderivative of 4x will be 4x squared over 2, or 4 over 2x squared. And our antiderivative of 6 will be plus 6x. And we're evaluating between x equals -1 and x equals 3. So this 4/2 we can simplify to 2. And then we can go ahead and plug in. So that will be -2 over 3 times 3 cubed plus 2 times 3 squared plus 6 times 3 minus -2 over 3 times negative 1 cubed plus 2 times negative 1 squared plus 6 times negative 1. Simplifying this a little bit, 3 cubed is 27. One of the 3's can cancel with the 3 here to get negative 18. 2 times 3 squared is 18. 6 times 3 is also 18. This will be minus negative 2/3 of negative 1. So there's 3 negative signs here, so it'll stay negative. So that'll be 2 over 3 minus 2/3. Here we still have negative 1 squared is 1. 2 times that is 2 minus 2. And here we have 6 times negative 1 for negative 6, but we're subtracting the negative 6, so it'll be plus 6.
Wait, isn't negative 1 just negative 1 cubed just negative 1?
It is, yeah. So let's actually not distribute first here. Let's go ahead and keep the parentheses. So that would be negative 1 times negative 2/3 for positive 2/3. This one will be plus 2, and this one will be minus 6. And then when we distribute, that'll be negative 18 plus 18 plus 18 minus 2/3 minus 2 plus 6. Does that make it more clear?
Yes.
All right, so let's go ahead and add these all up. These two just straight up cancel. 18 plus 6 minus 2 is 22. Minus 2/3 is 21 1/3. Or 64 over 3, I believe. Well, let's just go ahead and plug that in just to make sure that I didn't make that up off the top of my head. So that's minus 18 plus 18 plus 18 minus 2/3 minus 2 plus 6, which is 21 1/3, which is in fact 64.3 or 64 over 3. Sorry, did you have another question, Connor?
No, I'm sorry. I thought I did. I was wondering why it was 22, but I forgot there was a negative 2.
Yeah, the minus 2 went from 24 to 22. So, and there's your answer. All right, so in a few minutes here, I will post up some problems for you guys to work on these and practice with. I will be kicking around for another probably, yeah, it's about 55 minutes or so. I'll be here till 4:50 as usual, so you can come ask me any questions. Connor, if you will give me about 10 minutes to just get up all the materials from this class, after that we can talk a little bit and I can show you some ways of uploading stuff.
Sure.
Okay, so give me like 10 minutes to get some stuff out, and then you can jump on down to my voice channel and we can chat. Okay.
Okay.
Does anybody else have any other questions before I let you guys go for a while?
Real quick, for what we've already submitted, when will you be doing any grades on the other project stuff before?
Yeah, I probably should, huh? So that you guys can make any changes as necessary. I will have the other things all graded by the end of the day on Wednesday. So before Thursday morning, you guys should have some feedback. So if you need to change
Awesome,
anything,
thanks.
okay.
Thank you.
Yep. Any other questions?
Thank you.
All right, I will see you guys on Wednesday then.